Okay, so I know some people are still having some trouble with these problems, so I'm just going to go through a couple of them. I'm not going to do all of them, but a couple of them so that you can see how to do them, okay, if you're still confused. So the first one was just a real simple momentum problem, okay, with the color coding, the 22 kilograms, that would just go right down where it's pink, okay, it's a pink number, pink box, so we just put that down here, okay. 1.5 meters per second, that's the velocity, 1.5 meters per second, okay. So to find the momentum, momentum is always just P equals M times V, okay. So let me write that up here, P equals M times V. So we're just taking our mass times our velocity. So it's just 22 times 1.5. Okay. And when we do that, we get times 1.5, we get 33. Okay. The unit for momentum is just kilogram meters per second. Okay. And that's it for the first one. Okay. For the second one, again, it's color coded. So it says a 2 kilogram blob of putty moving at 4 meters per second slams into a 6 kilogram blob of putty at rest. The speed after they stick together, so this is inelastic because they're sticking together, is 1 meter per second. Is momentum conserved? Okay, so the first blob is moving across, hits the second blob, which is just sitting there, and they get stuck. This is very similar to the video where the guy was throwing the tennis ball in space, and the two tennis balls then got stuck together and started to move. Okay, so we take the pink mass here, 2 kilograms, and then we'll keep off the units for now. Okay, so if M1 is 2 over here, M1's got to be 2 over here. Okay, mass does not change. Okay. And then the 4 meters per second, that's the velocity, so it's moving at 4. Okay, and then we look at the mass of the blue is 6. Again, if M2 is 6 over here, M2 is going to be 6 over on this side. The blue, the second blob, is at rest. So if it's at rest, that means that it's not moving. Okay, so it's got an initial velocity of 0. And then after they hit, they're moving at 1 meter per second. So the velocity after is 1 meter per second. Okay, for this box, it's saying M1 plus M2. So you're just taking 2 plus 6 equals 8. Okay. So to find the momentums, momentum is always going to be mass times velocity. Okay, so I'll type that in here. So it equals m times v. Okay, so we're going to take, in this case, our 2 times our 4, which equals 8. And on this side, we're going to take our 6 times 0, which equals 0. Okay. So for the momentum, the total momentum before and after, all we have to do is add them up. Okay, so we're adding up P1 plus P2. So it equals P1 plus P2. So we take 8 plus 0 equals 8. Okay, and the unit for momentum is kilogram meters per second. And then on the other side, we do the same thing, but this time it wants us to use the M1, M2, okay, M1 plus M2. So we're going to use the 8 number, not the 6 or the 2, so just the 8. So we're going to take 8 times the V, which is 1, equals 8. Okay, so our momentum after, there's nothing to add since there's only one momentum, so it is just 8 kilogram meters per second. Okay. This is 8 and this is 8, so momentum is conserved. Okay, so we just highlight that. Okay, and I'll do one more example here. So this one here, it says Jason rolls a 7 kilogram bowling pin down the alley for the league championship. One pin is still standing, and Jason hits it head on with a velocity of 9 meters per second. The 2 kilogram pin acquires a forward velocity of 14 meters per second. The speed of the bowling ball is 5 meters per second. Is momentum conserved? Okay, so the mass of the first ball, of the bowling ball itself, is 7 kilograms. I'm going to put 7 here. And the velocity of the ball is 9 meters per second. Okay, again, they're both in the pink. So that's how I know by color that they are the before. Okay, the mass 7 is going to be the same whether it's before or after, because mass doesn't change. Then we have the pin. The pin has a mass of 2 kilograms, okay? And the pin's just sitting there before the ball hits it. So it's got a velocity of 0. So I already put that number in for you, okay? And then M2 is 2, so M2 on this side is also going to be 2. And then we look at after, okay? After they hit, it says the pin acquires a forward velocity of 14 meters per second. So now that pin, which was our blue area, is now moving at 14 meters per second. And the bowling ball is moving at 5. So it makes sense. The bowling ball was moving fast, and then after it hit the pin, it slowed down, okay? And the pin wasn't moving at all, but after the bowling ball hit it, it went flying, okay? So now we have to take our, to find our momentums of each, okay? Again, P is just M times V. Okay? So we're going to take our 7 times 9. Okay, 7 times 9, we get 63. And then we get 2 times 0, which equals 0. And then on the other side, we get 7 times 5, which is 35. Oops, equals 35. And then we have 2 times 14, which equals 28. So for each of the before momentum and the after momentum, we have to add up each individual momentum on each side. So on this side, it's just going to be 63 plus 0, which equals 63. Okay, and that's kilogram meters per second. And then afterwards, it's 35 plus 28, which equals, again, 63 kilogram meters per second. Okay, and as long as these numbers are the same, then the momentum is conserved. Okay, so they are the two I'm going to do for you. Feel free to throw that information in. The whole objective here is that you learn how to do it and not just copy. So make sure you're really paying attention to how these numbers got into each of the spaces. So that way you can easily do the next two by yourself.